Good day. My name is Ian Land. I'm the Senior Director of Aerospace and Defense Marketing at Synopsys. And I'm here today with Ken O'Neill, the Director of Space and Aviation Marketing at Microchip. And we're here to talk about radiation tolerant designs, working with Microchip's devices and Synopsys's tools. Welcome, Ken. Thank you for joining us. I wanted to go ahead and ask, how long has Microchip and Synopsys been working together regarding space FPGAs and space FPGA applications?
Synopsys has worked with Microchip and previously Microsemi and Actel for over 20 years since the early days of space FPGAs. Over the years, we've supported at least 10 generations of space-grade FPGAs, going back as far as the 2-micron process node. Today, we have in production 5 generations of space-qualified FPGAs, in addition to at least 7 generations of commercial FPGAs that leverage the Libero SoC design suite, which includes simplified RTL synthesis. In addition, Microchip FPGA product families are also supported by a robust verification flow from Synopsys.
That's fantastic. Amazing. 20 years is a long time to be partners and working together.
Yeah.
What are the challenges of making semiconductor devices work in space applications?
So there are many challenges for semiconductors in space. So I'll name a few of them. Shock and vibration from launch, booster stage separation, and satellite deployment. Radiation, both cumulative effects and single event effects. Temperature extremes and frequent temperature cycling. Power consumption and heat dissipation, since cooling requires radiation of heat into space, and reliability assurance and qualification. So we don't have time to go into depth in all of those topics today. So let's focus on radiation and power consumption. All microelectronic devices, including Microchip RT FPGAs, are subject to substantial radiation effects in space, including protons, heavy ions, and gamma rays. And the devices are subject to random faults and charge accumulation. So this is orbit dependent. It varies from low Earth orbit to deep space and interplanetary applications. And the Microchip Libero SoC design suite accelerates space designs, which includes utilizing simplifies automated methods to mitigate faults that occur from space radiation. And this supports all Microchip FPGAs, including the RT radiation tolerant FPGA families.
Excellent. That's very good. How do Microchip radiation tolerant FPGAs meet the challenges of space?
Yeah, so our radiation tolerant FPGAs have always had immunity to radiation induced upsets to their configuration due to the programming technologies that we use. And that remains true today with our latest radiation tolerant FPGA families, such as RTG4 and RT PolarFire FPGAs remaining invulnerable to configuration upsets, which means designers don't have to worry about scrubbing and reloading the FPGA configuration. And that ultimately is a saving in power consumption, bill of materials cost, and board space. So as I noted earlier, power is a big deal in space. Satellite electronics are limited to the power available from the solar panels, which tends to degrade with time and exposure to radiation. But an even bigger problem is, what do you do with excess heat generated in the satellite electronics? So you cannot have cooling fans in satellite electronics since they operate in a vacuum. So the only way to get rid of heat is to conduct it away and radiate it into space. So components which generate a lot of heat cause thermal management problems, which are expensive to solve. The programming technology we use in our FPGAs gives us intrinsically low static power, which really helps system designers manage the thermal issues in spacecraft. In addition, our latest RT PolarFire FPGAs have very efficient serial transceivers, which have best-in-class power performance characteristics. So this helps with thermal management in signal processing applications, which rely on serial data transmission from data converter to FPGA and from FPGA to backplane. The final piece of the puzzle is qualification. So we have qualified many families of radiation-tolerant FPGAs to QML standards, which are defined by MIL PRF 38535. Our RTG4 radiation-tolerant FPGAs are the latest to achieve a QML Class V qualification, which is the highest standard of QML qualification.
Okay, excellent, impressive products. How does Synopsys complement your radiation-tolerant family of products?
So Synopsys has automated synthesis mechanisms within Simplify to detect and avoid random faults, including support of redundancy and determination of critical design regions for radiation tolerance. Some of the automated mechanisms are triple module redundancy for memory, for I/O and logic, safe state machines, and memory error correction encoding. Beyond our Libero SoC design suite, mission-critical customers often work with Synopsys, who also offer verification and fault injection capabilities that observe and reduce faults, simulate and emulate faults, and support automated debug.
And can you provide a couple of example applications and how the joint solution benefits customers in those applications?
Yeah, sure. So our latest radiation tolerant family, the RT PolarFire FPGAs, use the same logic fabric as the commercial PolarFire FPGAs. So this means that unlike many of our previous space qualified FPGAs, there is no built-in triple module redundancy in the logic elements. RT PolarFire FPGAs are high density, high performance devices that are intended for high-speed data processing, where a single bit upset every couple of weeks amongst a torrent of data that's running at tens of gigabits per second is likely to be of no consequence. However, every data processing device has at least some circuitry where a much higher level of protection against radiation effects is needed. So for example, a configuration circuit or a command and control function. So Simplify works really well in this situation because it lets you apply TMR selectively to the parts of the FPGA design where it is needed without causing a performance and utilization penalty to the parts of the design that don't need it. So the power consumption of RT PolarFire FPGAs is also best in class, and the selective TMR capability of Simplify helps designers keep power consumption and thermal effects under control, again, by applying TMR or triple module redundancy where it is needed. So with Simplify selective TMR capability, you can have your RT PolarFire FPGA hosting a large data processing design running efficiently at full speed with a small fraction of the FPGA running a TMR or triple module redundancy protected command and control function.
Okay, that's impressive. Really valuable solution for our space customers.
Yeah.
Now, I'd be curious, how does that benefit commercial space customers?
Yeah, interesting. So the emerging commercial market has very similar challenges to the government space systems. However, they need to meet different cost and volume points. So the multiple microchip FPGAs and design tools combined with the automated tool capability from Synopsys makes it manageable for customers to support a range of cost and application needs.
Okay, excellent. Well, that brings us to the end of this interview. And I want to thank you, Ken, for joining us with this insightful discussion. Any closing remarks on your side?
Oh, you're welcome, Ian. Microchip and Synopsys, we're really excited to offer our joint aerospace and defense customers with state-of-the-art tools from Synopsys that complement Microchip's leading radiation-tolerant FPGAs. With this combination, we will help our customers usher in a new era of innovation, not only with government-sponsored space systems, but also with commercial satellites and space travel.
Excellent. Thanks again.
Sure. You're welcome.